Hello and welcome to my academy. So this is the third video on bisection method of numerical analysis. To watch the previous two videos, do well to look at the description of this video. I've posted a link to the previous two videos. Okay, so let's consider this question. It says find the root of the equation x minus cos s equal to 0 correct to 2 decimal places using the bisection method. Okay, so first thing, let's define our function. F of s equals s minus cos s, and I've said in the previous videos the very first thing we need to do is to find our closed intervals, so which means we need to find 2 points a and b. We need to find 2 points a and b such that when we put in these 2 points, when we put in a into this function, the function will be slightly less than 0, and then when we put in b into the function, it will be slightly greater than 0, which invariably implies that the function will turn from negative to positive or from positive directly to negative. So let's start. So the first thing you say, let s be equal to 0. So you simply find f of 0, and this is going to be, in place of s you put in 0 minus cos 0, and of course this is 0 minus cos 0 is 1. So this simply implies that f of 0 is equal to negative 1. Okay, you have this. So which means this result is less than 0 and it is negative. Again, we try another value of s to see if this is going to transpose directly from negative to positive. So let's set s to be equal to 0.5. Having tried 0, let's now try s to be 0.5. So this simply implies we find f of 0.5, which is going to be equal to, in place of s we put in 0.5 minus, in place of cos s you put in cos 0.5. And I mentioned in the previous video that if you're solving numerical method problem, especially the bisection method, and you encounter a trigonometric function, always put your calculator in radians to punch cos 0.5. So don't just punch cos 0.5, ensure that your calculator is in radians before you punch cos 0.5. Okay, so that means f of 0.5 is going to be equal to, so we have 0.5 minus cos 0.5, or 0.5 minus cos 0.5. Cos 0.5 is 0.8776, 0.8776 approximately. So this is going to be equal to 0.5 minus answer. This gives us negative 0.3776. Negative 0.3776. Now this value is less than 0 as well, and it is negative. So this value is less than 0, also negative, just like the previous value, but we want a transition from negative to positive or directly from positive to negative. So we try again, let s be equal to, since we've done 0, 0.5, let's try 1. So this simply implies we are now looking for f of 1. That becomes, in place of s we have 1 minus cos 1. Okay, so this is going to give us, so this is going to give us 1 minus, let's obtain cos 1. Don't forget to put your calculator in radian. So cos 1 simply gives us 0.5403, 0.5403. So this simply implies that f of 1 is equal to, so 1 minus that answer gives us 0.4597, approximately 0.4597. So you see this value is greater than 0 and it is positive. So there's a transition directly from negative to positive when x is 0.5 and when x is equal to 1. So in the previous two videos I've explained that the value that yields the function to be negative is called a. So a is equal to the value that gives the function to be negative and this is 0.5, so you have 0.5, and b is a value that gives the function to be positive. So b is simply when x is 1, we obtain the function to be positive, so b is equal to 1. So this simply means our interval, okay, this means our interval, okay, which is a and b, is now going to be, in place of a is 0.5 and b is simply 1. Now this simply means that the root of this equation lies between these 2 points. Therefore you find your initial guess, okay, you find your initial guess, which is s0, and that is equal to a plus b divided by 2, which is equal to a is 0.5 plus b is 1 divided by 2. So this simply implies that s0 is equal to 0.5 plus 1 divided by 2. That gives us 0.75. So you have 0.75. So s0 is simply 0.75, and that becomes our initial guess. Then we start our very first iteration using that initial guess. Okay, so we'll begin our first iteration. Not forgetting the function f of s is equal to x minus cos s. So you simply find f of s0 by plugging the value of s0 in this function wherever you see s. So in place of this s, we have 0.75 minus cos 0.75. So don't forget to always put your calculator in radian when punching cos 0.75. So we have 0.75 minus, let's obtain cos 0.75. That gives us 0.7317. So we take off the 4 decimal place, 0.7317. Okay, so this simply implies f of s0 is equal to, so 0.75 minus that result, this gives us 0.0183. we have 0.0183. now this value is greater than 0 and it is positive. So remember what I said earlier, when a value is being put into the function and it gives us positive, it simply means b is going to be that value, and the value we put in here is s0, and s0 is 0.75, so that means b is 0.75. so we form a new interval, now replacing b but keeping a. So in the previous interval we had ab, and a was 0.5, b lies on the positive side, which is 1. Now we have a new value for b, simply ac remains 0.5, but we have a new value for b now. B is now 0.75, so we have 0.75. so this becomes our new interval. So this simply means that the root of this equation lies between these two intervals. So with this we can now find the first root, which is s1. Okay, so we can find the first root, s1. S1 is also a plus b divided by 2, which is equal to, over here, 0.5 plus 0.75 divided by 2. So this implies s1 is going to be equal to, so let's find 0.5 plus 0.75 divided by 2. That simply gives us 0.625. So s1 is 0.625. Okay, so with this value of s1, or with this root, we can now find the second iteration. So we do the second iteration. Not forgetting f of s is equal to s minus cos s. So we find f of s1, which is going to be equal to, so in place of s in this equation, you plug in your s1. So in place of this s, you have 0.625 minus cos 0.625. so I will just punch this all together, so you can do well to punch along with me to avoid calculation errors. Okay, so you have 0.625 minus cos 0.625, so that gives us negative 0.1860. you have negative 0.1860. again, this value is negative and it is less than 0. So since this value is negative, remember, whenever a value is put into the function and it gives a negative result, it means that value will be called a. So that means a now will be changed. A becomes the value of s1, and s1 is 0.625. so which means a will now be called 0.625, since 0.625 caused this function to become negative. So a will become 0.625, whereas b still remains 0.75. That becomes our new interval. Okay, so our new interval becomes 0.625 and 0.75, which simply means that the root of the equation now lies between these 2 points. So you can find your second root, which is s2, which is now obtained by adding these two and dividing by 2. So you have 0.625 plus 0.75 divided 2. So this implies s2 is going to be equal to, so let's find that division. 0.625 plus 0.75 divided by 2, we have 0.6875. so we have 0.6875. so this becomes our second root. So we can now carry out the third iteration. Not forgetting f of s equals s minus cos s. Okay, now we plug in f of s2, which means whenever you see s in this equation, plug in the value as s2. So s2 gave us 0.6875. so in place of s here we have 0.6875 minus cos 0.6875. okay, so this simply implies f of s2 is equal to, so I'm punching everything together, so do well to punch along with me. So I have answer minus cos answer. This simply gives me negative 0.0853. so I have negative 0.0853. now once again, this value is less than 0 and negative, and once the value is less than 0 and negative, it simply means you fall back to your interval. Since the value is negative, remember, it means now that a is going to be equal to x2. Since s2 is what caused the function to be negative, then a becomes s2, because a is a value that transforms the function into negative. So a is equal to x2, and x2 is 0.6875, so a becomes 0.6875. so with this now we can form the new interval. Our new interval becomes, so remember, a is now changing, so we replace a from here. A becomes now 0.6875, and b still remains unchanged, 0.75. that becomes our new interval. Now, having found the new interval, it means now that the root of this equation lies between these two intervals, so we simply find the fourth root. Okay, so you find the fourth root, and s4 is equal to, so you simply add these two together, 0.6875 plus 0.75 divided by 2. So this implies that s4 is equal to, okay, so you have 0.6875 plus 0.75 divided by 2. That gives us 0.7188. So you have 0.7188 approximately. Now you can run your comparison. I've said that since the question says we should find the root of the equation up to 2 decimal places, you don't compare until you've done up to 3 iterations, which we've done so far. So we have S4 to be equal to 0.7188. Okay, so let's compare this with S3, which is the previous root. We had S3 to be equal to, okay, we obtained S3 over here at 0.6875. so S3 was obtained at 0.6875. now if you compare these two, they are not converged yet. This is 0.71 correct to 2 decimal place, this is 0.68 correct to 2 decimal place, so they haven't converged, which means we still have to continue our iteration. So we now find the fourth iteration. So we carry out the fourth iteration. Okay, not forgetting f of s equals x minus cos s. That's our f of s. So now we plug in, or we find f of s4, f of s3 please. So we find f of s3. Okay, so it turns out this is supposed to be s3, guys. This is supposed to be s3 and not s4. Okay, that's supposed to be s3 and not s4. So we find f of s3. So we simply plug in the values of s3 into the equation. So this is going to be equal to, in place of s, we plug in s3. s3 is 0.7188. So you have 0.7188 minus cos 0.7188. okay, so this simply implies f of s3 is going to be equal to, so let's obtain this value and see. So this gives us negative 0.0338. once more, this is less than 0 and it is negative. Since it is negative, that means we are still going to be considering a to be equal to s3. So this simply implies a will be considered as s3 and the value of s3 is 0.7188. so a is taken as 0.7188 since this value turned the function into negative. Now that means we are going to be forming a new interval. Okay, so the new interval becomes, in place of a from the previous interval, over here. Okay, let's just pull it down with it. So from the previous interval we had a to be 0.6875. now we are going to be changing this for a, but bc remains. We have a new value now for a, so we are going to be plugging that in. So our new interval becomes 0. This is now for a 0.7188, and of course b still remains 0.75. okay, so this simply means now that the root of this equation lies now between these two roots. Okay, so we can now find the fourth root. s4 is now equal to, we simply add these two and divide by 2. That is 0.7188 plus 0.75 divide by 2. This simply implies s4 will now be equal to, so let's find that ratio. 0.7188 plus 0.75 divided by 2. This gives us 0.7344. So s4 is simply 0.7344. now let's run our comparison. We had s4 to be 0.7344. now let's look at the previous root, and we had s3. previously we obtained s3 to be equal to 0.7188. 0.7188. so you compare this root. Correct to 2 decimal places is 0.73. Correct to 2 decimal places is 0.71. so which means only 1 decimal place has converged. 0.7, 0.7. This is 3 and this is 1 yet to converge. So which means we continue with our iteration. So you do this until at least 2 decimal places converges, which means they have the same values being repeated. Then you can stop your iteration. So with this, now you can find the fifth iteration. Okay, so we carry out the fifth iteration. Not forgetting f of s equals s minus cos s. Okay, so for the fifth iteration, we simply plug in s4 in the function, that is f of s4, which is now in place of s becomes the value of s4, which is 0.7344 minus cos 0.7344. okay, so that means f of s4 is now going to be, let's punch this value and see, minus cos answer. This simply gives us negative 0.0078. so we have negative 0.0078. once more, this is less than 0 and negative. Since it is negative, it simply means a will not be called s4. So this implies that a is now going to be equal to s4, and the value of s4 is 0.7344. okay, so our new interval becomes, so the previous interval we had here. So in the previous interval we had this for a, so we're going to be replacing this value of a with this new value of a, but b still remains 0.75. so we have 0.7344 and b remains 0.75. so that's our new interval. So this simply means now that the root of the equation lies between these two intervals. So we can find the fifth root using this given interval. Okay, so this is our new interval. Therefore, the fifth root, s5, equals 0.7344 plus 0.75 divided by 2. So we simply find s5 to be equal to, so let's sum this and divide. You have 0.7344 plus 0.75 divided by 2. So this simply gives us 0.7422. We have x4 to be 0.7422. So let's compare and see. S5. So S5 equals 0.7422. And let's check the previous value for S3. We had S3 to be 0.7344. So upon comparison, correct to 2 decimal place, this root S5 is 0.74. Correct to 2 decimal place, this root S3 is 0.73, which means they are yet to converge. So we continue with our iteration. Okay, so we can now carry out the sixth iteration. F of s, not forgetting, is equal to x minus cos s. So in place of s, we now plug in f of s5. This is going to be equal to, wherever you see s, put in the value of s5, which is 0.7422. So in place of this s, we'll have 0.7422 minus cos 0.7422. So this simply implies f of s5 is going to be equal to answer minus cos answer. This gives us 0.0052. Now this value is greater than 0 and it is positive. Since it is positive, it means now that we are going to be replacing s5 by b, since b is the value that always gives the function to be positive. So this simply implies b is going to be equal to s5. and S5 is 0.7422, so B becomes 0.7422. Now with this, you can now form your new interval. The new interval becomes, so remember from the previous interval we had A to be 0.7344, so A is constant now, it doesn't change, 0.7344. now we are switching B to this 0.7422, so 0.7422, so this is my B. Now this is now my new interval. So this simply tells us that the root of the equation lies in this interval. So we can find the sixth root, S6, that's equal to adding these two intervals, 0.7344 plus 0.7422 and dividing by 2. So this simply implies S6 is going to be equal to, so let's find this value and see. So 0.7433 plus 0.7322, 0.7344 plus 0.7422 divided by 2. This simply gives us 0.7383, so we have 0.7383. now let's compare this with the previous result. Compare this root to the previous root, which is x5 and s5. We obtain s5 over here. Okay, we obtain s5 over here. Okay, as can be seen here as 0.7422. Okay. So plug that here. This is 0.7422. So upon comparison again, correct to two decimal place, this is 0.73, this is 0.74, which means the value hasn't converged yet. So we'll further iterate. So we'll carry on the seventh iteration. Not forgetting f of s is equal to s minus cos s. So now we find f of s6, simply plugging the value of s6 in the function. So this is equal to, in place of s, we'll plug in s6, which is 0.7383 minus cos 0.7383. okay, we have this. So this simply implies f of s6 is going to be equal to, so let's find that value, answer minus cos answer. So this simply gives us negative 1.3138. Once again, this is negative and less than 0. It is less than 0 and it is negative, so which means we are now switching position of A. Since the result here is negative, this simply implies that A is now going to be equal to S6, and S6 gives us 0.7383, 0.7383. So we form our new interval. Our new interval becomes, in place of S, in place of A is now 0.7383. So A is changing from the previous interval. So let's take a look at the previous interval. So from the previous interval, this is the value of A. We are now changing A, but we are keeping B as 0.7422. okay, so we switch A now. A has a new value, which is 0.7383, 0.7383, and B is 0.7422. so this is our new interval. This simply means that the root of the equation now lies between this interval. So we'll find the seventh root, S7, that is equal to 0.7383 plus 0.7422. 7422 divided by 2. Okay, so this simply implies S7 is going to be equal to, so let's find that division. So 0.7383 plus 0.7422 divided by 2. This simply gives us 0.7403. So we have 0.7403. So let's compare this with the previous root. S6 simply gives us 0.7. So S6 over here gives us 0.7383. Okay, so that means 0.7383. Once again, upon comparison, the root has not converged here. This is 0.74 to 2 decimal place. This is 0.73 to 2 decimal place. So we keep on iterating. So it takes a lot of patience and accuracy, and you're going to be fine. All right. So we'll further iterate. So we'll carry on the 8th iteration. Okay, so not forgetting f of s equals s minus cos x. Okay, so we'll find f of s7. So this is going to be equal to, in place of f, we'll plug in s7, 0.7403. okay, minus cos 0.7403. all right, so let's see what we are going to obtain. Answer 0.7403 minus cos answer. So this gives us 0.0020. So we're having a positive value now. Let's flip the page. So f of s7 simply gives us 0.0020, which is greater than 0 and it is positive, right? It's greater than 0 and it is positive. And remember, whenever the function is positive, that means the value that caused that function to be positive is called b. So this simply implies that b will be called s7. And what is s7? We had our s7 is simply 0.7403. okay, let's pull it up. And we had s7 over here to be 0.7403. so we plug that in. So b becomes 0.7403. so our new interval now becomes, so which means b is changing but a is kept constant. So our interval become, a is kept constant. From the previous interval, a is 0.7383. so we have 0.7383. okay, and b is now changing to 0.7403. So this is now our new interval. So this simply means the root of the equation lies in this interval. Therefore we find the 8th root, s8, which is equal to 0.7383 plus 0.7403 divided by 2. This simply implies that s8 is going to be equal to, so let's add and divide by 2. 0.7383 plus 0.7403 divided by 2. So we simply have 0.7393. So let's compare this with the previous result again, comparing with s7. So we had s7 to be 7403. Once again, it hasn't converged, so we still continue to iterate until it converges to 2 decimal place. So we'll carry on the ninth iteration. So ninth iteration, again, like I said, it takes patience and accuracy, and you're going to be fine. Not forgetting f of x is s minus sine minus cos s, please. S minus cos x. Okay, so now we find f of s8. So this is going to be equal to, in place of s, plug in the value of s8, we'll have 0.7393 minus cos 0.7393. So this simply implies f of s8 is going to be equal to, so let's obtain the results, answer minus cos answer. This gives us 0.00035. So we have 0.000, okay, 0.00036 approximately. Now this value is greater than 0 and it is positive. Okay, so since this value gives us positive result, it means it's going to be replacing b from the interval. So it means b is going to now be equal to s8. Okay, this simply implies that b will be equal to s8, and we had s8 to be 0.7393, so b is equal to 0.7393. so we formed a new interval. Our new interval becomes, previously our interval we obtained, okay, we are going to be keeping a now, right? So we are changing b, so a remains 0.7383, so we are simply changing b and replacing b with this new interval. So a remains 0.7383, whereas this remains b 0.7393, so b becomes 0.7393. so I think at this point the root is going to converge. Well, let's try and see. So we find the ninth root, s9, which is now lying between these 2 points, 0.7383 plus 0.7393 divided by 2. So this simply implies that the ninth root, s9, is equal to 0.7383 plus 0.9 plus 0.7393 divided by 2. That gives us 0.7388. Okay, so comparing this with the previous root we obtained, which is s8, we obtained s8 over here as 0.7393. so s8 was given as 0.7393. so correct to 2 decimal place, this is 0.73. correct to 2 decimal place, this is 0.73. so which means the root has converged. Therefore the root of the equation correct to 2 decimal place, the root of the equation correct to 2 decimal place is 0.73, and that's the answer. Alright guys, so I hope you found this video interesting and helpful. In the next video we are going to be looking at the bisection method of the equation involving logarithmic function. I'm sure you want to be a part of that video, so do well to hit the subscribe button and turn on your notification bell so you don't miss out when that video drops. I hope you find this video interesting. Do well to like, share to your friends, comment nicely, and subscribe if you're new to the channel. I will see you in the next video. Thanks.